So, good morning, everyone. So, we built an ark, and it's a robotic ark. It'll be coming to pick you and take you home after this week till rain. So, I want to thank you all for taking the time to come out. I know it's been a tough week of rain in Maryland and the Northeast, and we're delighted to have all of you here. My name is Darryll Pines, and I'm the Dean of the A. James Clark School of Engineering, and this is our second annual celebration of robotics research and education here at the University of Maryland. Today has been made possible by a number of people. First and foremost, this is sponsored by the Maryland Robotics Center, housed within the Institute for Systems Research, a center that was really initiated thanks to a group of about 20 to 25 faculty members and their students and their interests that we've been working in robotics for over maybe 20, 25 years. And last year, the center was inaugurated essentially in April, and we had our first robotics day with over 500 attendees. I think the weather has really affected us this time because we actually have even more people supposed to come this year. So our new Maryland Robotics Center would not be possible if it were not for the leadership of ISR Director Dr. Reza Gupta, who holds the Herb Raven Distinguished Professorship of Electrical and Computer Engineering. I'm also grateful to Mechanical Engineering Professor S.K. Gupta, who's the Director of the Maryland Robotics Center. And finally, I want to thank those faculty members, the 25 or so faculty members from across the college, across the university, who have really supported this initiative as we went forward to really solve those truly hard problems that will affect the grand challenges that our society faces. So I'm sure when you think about robotics, you may not think of the University of Maryland here at College Park. You might think of our new uniforms, though. But I want you to now start thinking about robotics. I was thinking about coming in with one of those new uniforms on, and making it robotic. I said, no, I shouldn't do that. By the way, we were auctioning those uniforms, just as a side note. No, those were one-offs. They were only done for that game. And so now they're actually going to auction. And they didn't ask me to say that. I'm just telling you that. You don't have to do anything. I just thought you think that would be funny. It definitely was the talk of the town for last week and ESPN and all the blogs. So hopefully we need to do something like that for robotics. But anyway, the faculty in ISR and throughout the university have been working on robotics research for over 2 decades. Based on our long history of accomplishments, a group of faculty in this college decided that this was an important area, collective activities they wanted to bring together in a more forceful and definitive way. So they established last spring the Maryland Robotics Center. Our goal in this new center is to harvest the truly creative spirit and innovative activities that are being explored as it relates to all robotics into a collective, cohesive team of scholars. More importantly, our faculty, staff, and students are working on things that will truly have a significant impact on our society and our quality of life. We have created the Maryland Robotics Day to highlight some of these activities so that successful partnerships might be established between industry, government, and academia. In addition, our goal is also to facilitate technology transfer to enhance economic development. For many of you who are as old as me, or older, maybe a little younger, your first introduction to robotics may have been through various science fiction novels from Arthur Clarke. Or maybe it's through the classic movie, the 1968 legendary movie, 2001 Space Odyssey, or HAL, which stands for Heuristically Programmed Algorithmic Computer, is an artificial intelligence computer which interacts with the crew, usually represented only as that red eye. You remember that? If you're old as me, you remember that. So remember some of the comments that Hal used to say? He would communicate to the crew in a very soft, methodical voice. I am sorry, Dave, but I cannot allow you to disconnect me. It can only be attributable to human error. So this was Hal. This was sort of my first introduction. I was 4 years old watching this movie. Or maybe your first introduction was through watching R2-D2 and C-3PO in the movie sequels to Star Wars. Or maybe it was through the television series Lost in Space, where the robot says to the boy Will Robinson, every time there's an impending threat, danger, 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 Will Robinson, danger. I say that to the faculty now, and any time they try to pass me to get money from the provost. I say, danger, danger, don't do that. Well, whatever your first exposure was, we have truly come a long way from those early days. Today, robots are used in every aspect of our lives, including manufacturing of vehicles, cutting your lawn, vacuuming your carpets, and many other goods and services. For example, it is quite common to see an automated car wash these days. These things didn't even exist maybe just 10, 15 years ago. So you drive into a gas station and you can actually have a robotic system essentially give you a car wash. It costs you about $10, right? This past year in May, you heard about a man who was paralyzed and confined to a wheelchair but wanted to walk across the stage to receive his diploma. Do you remember that story? He was able to do that with the assistance of an exoskeleton structure that reinforced his joints and his motory functions to enable him to get out of his wheelchair and literally walk across the stage, receive his diploma, and shake the dean's hand. It wasn't me, it was at another school. I wish he was here. This was a very proud moment for robotics, a very proud moment for the exoskeleton community as well. So you might ask, what is next? Today you will have another futuristic science fiction experience in 2011. Imagine that you might see a micro-air vehicle completely controlled by the signals from the human brain. Or imagine an exoskeleton system that can help accelerate rehabilitation of soldiers whose limbs have been injured or lost in battle and require physical therapy. You will see these kinds of things today. Or imagine the next generation of medical robotics that will completely automate the neurosurgery process with minimal invasion of the human body. Or imagine a bio-inspired micro-robots that leverage the biological principles from insects and birds that enable mechanical systems to walk, crawl, hop, move through water, and fly, all leveraging our greater understanding of how nature really does this. All of this you will see today in the many laboratories that will be featured throughout the day from 10 to 3. The future is now, and it's here at the Clark School of Engineering. I hope that after you leave today, that you will now attribute robotics to the Clark School, and you will seek new partnerships with us in the future. So ladies and gentlemen, welcome to the Maryland Robotics Day, and please enjoy the future of robotics as we present it to you later today. Please join me in welcoming Dr. S.K. Gupta, who will come up from the director, he's the director of the Maryland Robotics Center, and tell you about what we're doing in robotics, and then introduce our keynote speaker. Please welcome Dr. S.K. Gupta.
So thank you very much. People in the back, can you hear me? Okay, sounds good. So thank you very much for taking time from your busy schedule and fighting the weather and visiting us. And partly you have been pretty rough out there. So what I'd like to do would be give you a brief introduction about our center, and then we'll get on to the program with the keynote speech by Borgia. So Maryland Robotics Center, as Darryll pointed out, is located in the Institute for Systems Research, which is a interdisciplinary systems-focused research center, which was an institute which was formed more than 25 years ago. And this institute is located in the Clark School of Engineering, and that basically makes sure that our robotics activities span all different facets of robotics, going from the hardware to software to new application areas, and also doing some fundamental cutting-edge research in system science. Center consists of 30 different faculty members participating from a wide variety of academic departments on campus, and consists of 18 different labs. And I believe out of those 18, you're going to see 15 labs today. The main thrust for our center are in 5 different areas. The first thrust in which the center works is called collaborative network robotics. So in this case, the idea is lots of small robots which are going to work together to solve really complex problems. Second thrust is in the area of unmanned vehicles. So in that case, we are interested in basically building a wide variety of vehicles which can not require human presence on the vehicle. So these go from unmanned boats to unmanned air vehicles, to underwater vehicles, to ground vehicles, as well as some space type of platform. The third area in which we work in is miniature robots. So here the idea is that we want to create robots which are very, very small, or alternatively robots which can operate on things which are very, very small. Fourth thrust is the medical robotics area. So here we are trying to build robots ranging from physical therapy to surgical interventions. And the final area is robotics in extreme environment, where we are interested in building robotic platforms for deep underwater exploration, as well as space applications. So those are the 5 cluster areas. So, and we are also very active in robotics education. We have really truly creative courses we focus on robotics education, ranging from autonomous robots to bio-inspired robots, medical robots, as well as we are very active in the robotics competition as well. So what's happening nowadays a lot is that people are beginning to debate that this robotics is great, but what is in fact going to be on the jobs? Some people are arguing that the robot may take jobs away from humans. And if that's the case, then perhaps robotics now is not the right time for robotics. So let's get that discussion started. I thought that I'll share my thoughts on that topic with you, and also tell you what kind of robotics technology we are working on, so that that's not going to happen. So before I get into that, let me just talk a little bit about a new perspective that's emerging in the robotics, as the robotics community basically is exploring new robotics applications. So people are beginning to think about robots as tools that are going to amplify your abilities, or amplify humans' abilities. So this is a very human-centered view of the robotics. Human is at the center, robots are just a tool which are going to make you more able. So the idea is that using robots, you'll be able to see things that you cannot see with your naked eyes. So imagine that you are in front of a hill, you want to see what's behind the hill. You can take out a little bird from your backpack, launch it, fly it, let it go the other side, see what's there, and fly back. Imagine a situation where you are in a building, certain emergency situation arises, and you need to find out how to get out of this building. So once again, robotics come to rescue. You have some robot who can tell you what the situation is, and that helps you figure it out what would be the best evacuation plan. So again, human is right at the center of, human is just using the robots as tools. Also, we are limited by what our hands can do. So there are certain situations where you want to access space which is highly constrained. So for example, if you want to perform a minimally invasive surgery, in that case you want to access human body to a very small cavity. So once again, robot comes to rescue. You have these robots that you can operate and actually perform surgery. The certain tasks that you want to do very fast and very accurately. Once again, robot helps you do that. So the idea is, once again, human is at the center, robots are the tools which will help you do better sensing, better actuation, better information processing. So now let's talk, so that was, abstract concept. So let's explore that idea a little bit in the context of 4 different applications. So the first application is basically use of robots in medicine. Clearly, in this case, people are designing, building robots which are going to enhance the capability of physical therapists and surgeons. Nobody is talking about robots replacing physical therapists or surgeons. So the doctors don't need to worry about basically selling their BMW universities. They are perfectly fine. They can live in the big houses, so things are going to be fine. Now, similar situation actually applies to a wide variety of other scenarios as well. So when people are talking about robots aiding first responders, food safety inspectors, teachers, disaster relief workers, once again, robots are just going to be the tools. Nobody is talking about replacing any of these people. So the point that I was trying to make is that in all these application scenarios, all robots do is that let humans do their job better and create a better outcome. That's all robots are going to do. So now let's pick another example. So a lot of people are predicting that the biggest growth in the robotics is going to come in the personal use market. So what kind of things people are talking about? Autonomous car. So you can drive from your house to your workplace in an autonomous car. You've heard about home cleaning robots, lawn care, snow removal, entertainment, toys, and on a serious note, prosthetics. Now, once again, if you think about it, just because you happen to use an automated car that drives you from your home to your workplace, you're not going to fire from your job because of that. So clearly, any growth in personal robotics is not going to take jobs away from you. Or perhaps our kids who are making some money by doing chores at home, or maybe they will not be able to work the chore will be done. But on the other hand, if you think about it, once you're going to get your new robot and you want it to start working and install it, you need the help of the same kids, right? So I'm sure that they will make more than enough in whatever they lose in the children. Robots in scientific exploration. So people are interested in basically using robots in space exploration, in deep ocean exploration, volcano explorations. So you have a choice to make. You can basically create a device which will ensure the safety of human occupants, and you send that device. Or you can simply say, I'll take risk, not send, and create a device which is relatively cheap. There's a chance that it won't work, but there won't be any human in it. So for the same amount of budget, you can actually do not many more robotic explorations than what you can do with human-based exploration. The back end of it, what happens is that if you're doing robotic exploration, it creates a lot of data which comes back. And that creates now new jobs for scientists and engineers and analysts who can analyze this stuff once the data start coming in. So once again, what happens is that even though I hope that nobody in the audience is astronaut will get mad at me because few astronauts will lose the job. But on the back end, you're going to pick lots of other jobs which will be basically analyzing, processing, and doing things with the data which robots are feeding. And you will be seeing, robots which are capable of assisting in these exploration missions in several civilizations today. Now, similar argument applies for surveillance as well. So when you talk about surveillance, robotics, same way, really have net positive impact on jobs. Another scenario that I want to explore is manufacturing. So what has been happening in the United States in manufacturing is that due to very high labor cost, a lot of jobs basically, you cannot see costs competitive, and hence a lot of jobs in the US. If we can have next generation robotic platforms that can work side by side humans and collaborate together, then what you can think about is a scenario where menial jobs are taken away from humans, but skill-based jobs are still there, where humans are creatively. So, example would be Maryland used to have lots of molding shops. Long time back. They're very few left. Why? Because molding has a skill-based components and basically a lot of manual labor involved, right? So imagine a scenario where people can design very good creative molds, but the polishing of the mold job is done by the robot. And hence, we are cost competitive, and we can actually do that thing right here in the state of Africa. So what happens is that if you can have this hybrid model of humans and robots working side by side, then you can retain a lot of manufacturing jobs which otherwise would be lost. And not only that, but you can actually bring jobs back to the US which you already lost. So in that scenario also, the way things are that utilizing robots will have a net positive impact on robotics. I mean, you will see some example of where we have creatively utilized robotics and make some nice artifacts. So that's an example. So until now, we talked about basically how different applications which are going to utilize robots can get impacted in terms of jobs. But if you think in terms of if robots are widespread, everybody's buying one, then there'll be a robotics industry which will be created. And that industry itself will, create lots of jobs. Designing, making robots, writing software for the robots, as well as basically installers and servicing these robots. Now the question is, who is going to be playing a major role in it? Clearly, US is a player, but there are others, such as Japan, Korea, Germany, but you have to see who becomes or emerges as a major player in this field. And whatever jobs that get created as a result of this robotics industry, the next question is, how many of those will actually come to the state of Maryland? I hope lots of them. And our center can contribute to them. So in summary, University of Maryland has a comprehensive program in robotics. We have 18 different labs which offer capabilities. We have 30 internationally recognized faculty members who do different facets of robotics. We have some of the best students in the college which work in the robotics, and you will have an opportunity to meet and see lots of them later today. And I personally believe that next generation robotics, which is human-centric robotics, actually will contribute positively to the job picture. So with that, I'm going to conclude, and I can take any questions. Okay? Yeah, go ahead.
What factors determine which countries will be the leaders of the robotics industry?
Lots of factors. It depends on basically the research component of it. Right? That you have to come up with a new idea to see which country is able to contribute. It depends on the manufacturing base. It depends on the applications, where the applications are there. So there are lots of different components which will contribute to which country in the end wins. Okay?
Yeah, you were talking about manufacturing, and you made some reference to advanced robotics or next generation robotics.
Right.
What do you really mean by that? And where do you see the line between current industrial robotics and what we do today?
Right.
Right?
So currently, robotics get used a lot basically where you have mass production lines, right? So where you can completely control your factory environment, and you design a robot, you deploy it, it's going to work for a couple of years there, and the part gets presented to the robot in a completely structured setting. So that's where robotics is being deployed in a big way. But if you go to small volume manufacturing, custom manufacturing, people don't like to use robots because it takes a long time to program and set up a robot and figure out how you're going to present the part to the robot. So that's where people are not using robots. So the idea there is that the robots, which can actually be programmed very easily and reason about the artifact itself and figure it out what they're going to do on it, right? So you need both of those components to start migrating the robot from the automotive manufacturing lines to actually small job shops. Okay, so very quickly, because I really want to get going, so we can talk offline. So it's my pleasure to welcome Borgia from Lockheed Advanced Technology Lab. He directs that lab here, and prior to being at the Lockheed Technology Lab, he was actually heading the Army CTA program. My pleasure.
So, good morning. Yeah, why don't you go to the video and then put it on pause, and then I'll introduce the video. You want to put it on full screen as well, please? So, good morning. I know a lot of people out there have sometimes have some fear about robotics and whether they'll take jobs, like SK mentioned. Well, I'm glad to be an honorary terrapin for the day, and I want to tell you that you should fear the turtle and not the robots. I woke up this morning and I had a new idea for a personal robot. I took a shower and I looked in the closet of the hotel room and I quickly realized I forgot my trousers. And luckily for everybody here, I solved that problem. But I was thinking, if I were leaving the house and needed a way to remember what to bring, inevitably I always forget something. Would I have a personal robot that could tell me what to remember and what to bring? And how much would you have paid for that device if it can tell you what to bring? Well, I think the answer to that question was about $30, because luckily I was able to rectify the situation for that price. But there are a lot of applications, and I think a lot of societal impact for robots, and I want to reinforce and amplify some of the things that SK mentioned earlier. First of all, as SK mentioned, I'm the lead of what's called the Intelligent Robotics Lab, and that's part of Lockheed Martin's Advanced Technology Laboratories, and we are primarily based outside of Philadelphia. And we have 5 labs, and of course one of them focuses on intelligent robotics. Now, what do I mean by intelligent robotics? So what that means are the capabilities and the technologies that help enable higher levels of autonomy, that help robots make more decisions on their own. And then the Intelligent Robotics Lab lives within what's called the Advanced Technology Lab, as I mentioned earlier. It's our job to work on and investigate what are called disruptive technologies that could be entirely new businesses for Lockheed Martin. If you think of all the business areas that companies like Lockheed Martin are involved in, be they space technology or fighter aircraft, ultimately all of those technologies are going to go obsolete. Ultimately everything goes to zero. Well, that's all our job as the Advanced Technology Lab, to be thinking about what are the new technology waves, what are going to be the new enabling technologies that will enable us to compete in the businesses that we want to be involved in the future. And so that's our job at the Advanced Technology Lab. And we have about 30 people in our robotics lab who are working on technology to advance the state of the art in robots and robotic autonomy. One of the efforts that I want to talk about just slightly to give you an idea of what we do in the Intelligent Robotics Lab is a drone or an unmanned aerial vehicle that's based on maple seeds from nature, and we call it Samurai. If you think of the maple seeds that fall from the trees throughout the year, they look like a very simple single-winged airfoil. As they fall from the tree, the airfoil generates lift, and the trees are able to spread their seeds over quite a distance. Well, we've taken that technology, the nature's technology of the maple seed, and we've added very simple power and control to the maple seed, and we've been able to generate a very simple, low-cost unmanned aerial vehicle that could be used, as SK mentioned, for surveillance applications, to see over the hill, to see around the building. And if you're a soldier on the battlefield, you can deploy these very quickly. You can actually pull them out of your pocket, throw them up in the air just like you'd launch a maple seed, and you have a very simple vertical takeoff and landing UAV. And it enables a lot of urban operations that, again, aren't possible without robotics and aren't possible with fixed-wing aircraft technology. So I'll show some video. And Samurai is technology that we started investigating about 5 years ago. It began under sponsorship of the Defense Advanced Research Projects Agency, and we've built these in a number of different scales. We've built a 1.5 meter scale vehicle. We've built about a 30 centimeter vehicle, and recently we've also started printing these using 3D printing technology, using stereolithography. And so we can print these in almost any scale. And the real challenge here is actually not in printing the airfoil or making the physical device. The real challenge is actually controlling this vehicle. If you think back to traditional aircraft, be it helicopters or airplanes. Usually control is a combination of a number of different control surfaces: ailerons, elevators, rudders. You have a lot of control surfaces. We have a lot of linkage and cables between those. What we do in Samurai is very different. We were able to combine 2 moving parts, power and a very simple flap. And by applying advanced control technology, we're able to control this in 3 degrees of freedom. And so again, it's a very simple device. We can produce these at a low cost, and so they can have a lot of impact for not just soldiers in the military application, but also a lot of impact outside the military for police and fire and for disaster rescue. So a lot of applications for technology like Samurai. And ultimately, Samurai might become a product someday for Lockheed Martin, and that would be wonderful. That would be good validation of some of the research that we do at the Advanced Tech Lab. But more importantly, from a robotics perspective, what we get out of investigating technologies of biologically inspired robots like Samurai, is we also learn how to control mechanically simple, mechanically challenging vehicles. And by doing that, We gain expertise in controlling biologically inspired robots that have all kinds of applications. So by controlling a mechanically simple platform like Samurai, we learn how we can control maybe a micro robot or a very simple robotic manipulator. And that, again, opens the door to applications that go well beyond just the surveillance application that I've demonstrated here with Samurai. So, but I think, as SK mentioned, I'll go over some of this again. Robots help us solve a lot of real problems that we have in society, and they help amplify the work that we can do as humans. So we've mentioned security and intelligence challenges. We have a lot of those in our country. We also have a lot of aging infrastructure that needs to be inspected and maintained, and a lot of that is in complex and challenging environments. We can't always get to it with humans, so robots enable us to inspect and repair and maintain infrastructure that can't easily be accessed by humans. Robotics in surgery and in medicine, again, they're not replacing the physician, they're letting him do more with the technology that he has. Robots in manufacturing, obviously we touched on that, and I'll amplify on some of the ideas for how robots can make us actually much more competitive in manufacturing than we are. And also, and I think I need to mention this at a university, is that also robots are starting to have a big impact on how we teach math and science and computer science in our schools. And you're seeing a number of robotic competitions that have been extended down to the high school and the middle school level and even beyond. With the FIRST Robotics program, for example, and the robots that are based on Legos. It's very different than when we were educated and when we were given problems in math and science that seemed sometimes very contrived. And we always had people that asked us these questions, oh, I'm never going to use this math ever again, why do I need to know it? Well, we can start applying some of those technologies with our hands-on using robots. And when kids can see robots moving around their desks or around the classroom, they get much more intrigued about learning math and science. And robots, I think, are going to go a long way in helping us educate more young students in math and science, which is a critical need for our country. And so robots will help build some of that enthusiasm that we need to start rebuilding that area of our society. I also think that with all these applications, robots have the potential to become a very big business. I think that, for example, if you think of computing and how computing evolved in the last 70 years, there was once one of the CEOs of IBM said back in the 1940s, he forecasted that someday the United States would have the need for approximately 6 computers. So most people here probably have 2 computers with them in the cell phones that they carry today. The reason for that is because the engineers who designed computers way back in the 40s, or even who designed PCs in the late 1970s, they could not foresee all of the potential applications that there were. It took us getting computers in the hands of the users who could think of the more applications for robotics that went well beyond what the engineers could think about. And you see the same thing in the last few years with the ecosystem that's been created with smartphones or with iPhones. By the time we got smartphones in the hands of users, the number of apps or applications that appeared exploded. And they went well beyond what Steve Jobs would ever think about, because he knew that all he had to do was get a general purpose platform out into the marketplace, and the users themselves would think about those applications. And I'm sure, again, each of us have smartphones, we've all thought of different applications, and many times we've probably implemented them because they're pretty easy to implement. I think we can do the same thing with robots, and we've seen very minimal penetration of robots into the consumer market today, but that's picking up. And as we continue to do that, and as those robots that we bring out into the market have more of a general purpose, we'll think of more applications that we can use for those robots. And they'll explode, because once the users are thinking of those applications, we'll be able to generate applications that us engineers have never been able to think about. And then, as I mentioned, robots are also very important to my company, Lockheed Martin. We're involved, as most people know here, in a number of different business areas. Manned aircraft, commercial and military space, to name a few. And robots not only have the potential of touching upon every business area in Lockheed Martin in terms of a building products perspective, But robots are also going to be very important for our processes. We think about applying robots to manufacturing, assembly, and logistics. Robots have a tremendous number of applications within our own company. And so that's why I think it's a really exciting time to be involved in robotics, because there's been a lot of great work that's been done to date, but there's a lot more left to do. And we're really at the inflection point of where robots are going to go. And the reason for that is because, again, we're now starting to see general purpose robots penetrate into a lot of different markets. Getting them into the hands of the users is going to help us think about a lot more applications. So let's first touch upon some of the work that's been done to date. For example, let's talk about, we talked about automated driving or driverless cars. Automated guided vehicles go back to the 1960s and have been used in manufacturing and logistics automation for quite some time. Here at the University of Maryland, Larry Davis was involved in what was called the Autonomous Land Vehicle Program. That was the first robotics project for autonomous driving. Went back 25 years. For example, Hugh Durant-White from Australia has been doing a lot of work in robotic mining and in logistics and container loading. Everybody's heard in the news about the use of drones or unmanned aerial vehicles in a number of military applications. They're also starting to penetrate into civilian applications. Home robots, a lot of people in here probably have Roombas or Scubas or machines that help them around their houses. Those are typically targeted at specific applications. I'm thinking about how we're going to take those robots and use them in a more general purpose. We talked about medical robots and the use of the Da Vinci surgical system. That comes out of actually work that the Army had done with remote surgery. Also, casualty evacuation is an area that's very important to the military because it's a very risky application, and there are a lot of research initiatives. And as SK mentioned, many of these applications that we're talking about can't be done safely or can't be done effectively with humans alone. Some of these applications truly take some level of automation to achieve them. And it doesn't take the human completely out of the loop. It lets the human do more with the tool that robots enable them to do. And so I think going forward, I'd like to talk about some of these benefits that robots are going to have in society. Well, let's first talk about some of the societal factors that I think are going to help drive some of that. Number one, our population is aging at this time. In a few more years, we're going to have almost as many people that are retired as we have working. And there are a lot of people that we need to take care of, and we need to assist them to stay in their own homes. And there are a number of applications we talked about earlier with robots that can help people clean or robots that can help people stay in their homes. And so this is going to help us drive the marketplace for a number of general purpose applications of robotic technology. So that's factor number one. Number two is our country is faced with security challenges that continue to increase. And if you look at the types of conflicts that our nation engages in, we're seeing a lot more low-level conflicts, and we're seeing a lot more wars of insurgency, a lot more wars where using big power techniques that we've used traditionally are just not working for us. And we're also seeing at the same time, as the security challenges are going up, we're seeing our ability to pay for those security challenges actually go down or remain steady at best. And so again, robots are a way that we can amplify the number of people that we have. If you look at where the military spends most of its money, it's actually not in procuring systems, and it's not in what they pay defense contractors like me to do. What most of the money that the military spends goes to is in operations and maintenance. The vast majority of that money goes to operations and maintenance. And so we're seeing, as we get into a very challenging situation with our federal budget, we're seeing the need to do more with the people that we have, achieve more with the people that we have, or even what I call, we need to do less and do it more often. The challenges that we face change very quickly, and so what robotics and general purpose robotics help us do is react to some of those challenges much quicker. And again, use the personnel that we have, use the soldiers, the sailors, and airmen that we have more effectively, and help them work alongside them in applications that will help them amplify their power. And I think that's going to be necessary, not just for the insurgencies that we see ourselves engaged in, but then in the peacekeeping missions that come after that. Robots can go a long way to help us address some of those applications. Well, let's think back into history. When we think about this idea that robots are tools, we've seen a lot of automation that's come along the line in the last 100 years, especially since the Industrial Revolution. And none of that would have been possible without machinery. In fact, since the Industrial Revolution, we have far more people employed than we did pre-industrialization. When we were an agrarian society, we had a lot more people who were subsistence living, who were not employed. Well, since the Industrial Revolution, we've been able to achieve almost full employment for the past 100 years. And we've only been able to do that with machinery. There are certain things there are a number of initiatives that we've embarked on as a society that were only possible with machinery. You know, imagine being able to dig the Panama Canal if we didn't have some sort of automation or some sort of level of excavation equipment. We couldn't have done it with using manual labor. We couldn't have built the infrastructure that we've done in the last 100 years using simply manual labor. And so we've employed tools not to replace humans, but we've employed automated tools to help us amplify the power of humans. In a sense, we're building a bigger pie. We're building a bigger pie that we can all then share. And by continuing to increase the level of automation or increase the capability of the tools that we use to solve society's problems is how we've been able to really advance our society over the last 100 years. And we're going to continue doing that with systems like robots that can adapt to their environment and can start thinking about what their environment looks like. But there are also other dangerous tasks that robots can get involved in that, again, we would never think about sending a human into. So one of the seminal events that robots were applied to about 30 years ago was the partial nuclear meltdown at 3 Mile Island. And that speared a lot of robotic research. And we never would have thought of sending humans in to the nuclear plant and to measure radiation or to help with some of the cleanup. We never would have thought about doing that. That's another application that robots can be used alongside humans to do things that humans can't do. And you saw the same thing with Fukushima this year in Japan. We sent robots in to assess the situation, and then we can also start to deal with the decontamination using robots. And there have been robots built for that purpose. And again, we would never think about using humans because it's just too dangerous a mission. And then finally, in medical robotics, everybody in here has heard about the Da Vinci surgical system. So again, the surgeon sits at a console. So we don't take the surgeon out of the loop. We let him work more effectively. The surgeon sits at a console, but also there's a lot of benefit to the patient by using medical robots. Okay, we can, instead of having to do an open procedure for, say, removal of a prostate, we can make a very, very small incision with a robotic tool. And then, so the patient has a smaller incision, the time of recovery is a lot lower, he loses a lot less blood in the surgery, so it increases recovery time. But also, the surgeon, again, he sits at a console, he doesn't have to stand for the entire 6 or 8 hour procedure as it is sometimes. And his movements are dampened. If you think about how delicate the human body is, especially after you open it up, if you think about just how delicate the human body is and the interactions between the organ that's being operated on and the blood vessels and the nerves, there's a lot of probability for error. And I'm sure, as everyone knows, when you try to keep your hand steady for even a couple of minutes, it's very, very difficult to do. It's a very, very tedious task. Well, one of the things that the Da Vinci surgical system does is it helps dampen some of those motions that the surgeon can make. And so it tremendously reduces the probability for error in surgery. And so again, here's an example of where the human's still in the loop, but he uses the robot as a tool so that he can work much more effectively. And so these are just a handful of areas, aside from manufacturing, where robots have a tremendous benefit. And we're only going to see more of that as we continue to deploy robots into the market and as we continue to put them in the hands of users who will identify more applications. Let's talk specifically about manufacturing. That seems to be the 800-pound gorilla that we see with respect to the job situation that we have today. Well, I look at manufacturing and assembly as being twofold. We have manufacturing of very simple products. If you think of toys, or maybe even iPhones. That manufacturing is always going to search for the lowest cost. So in the last 60 years since World War II, first we saw that manufacturing going from the U.S. to Japan, and recently it went from Japan to China. Well, now we see that China's actually losing manufacturing because companies are finding lower cost in Vietnam or in Pakistan. So the low cost, the simple manufacturing, that's always going to that's always going to go toward the area of lowest cost. But actually, the United States today is still the #1 value-added manufacturer in the world. And by value-added, what I mean is we put the most value in the goods that are manufactured. And so when you think about it, those aren't the toys, those aren't the simple products. Those are the highly complex products that can't completely be put together by a machine. They require some level of cognitive input, some level of cognitive use of the human. And what the human is best at is not the repetitive tasks that can be automated with machinery. What the human is best at is doing those cognitive level tasks. And so what robots enable us to do is let's take those simple repetitive tasks, put those in the hands of the robot, and then the humans that work in manufacturing and assembly can be used much more effectively. And so now we would be paying those humans to do what they can do best. That can help manufacturing companies maximize the value of the employees that they have. And again, because they're using employees to their maximum value, they're recognizing their cognitive potential and not their repetitive potential. They recognize their cognitive potential. We can help keep manufacturing here in the U.S. And again, as the #1 value-added manufacturer in the world, the way that we can maintain that position is to increase the level of automation, increase the size of the pie, and let us do more with the workers that we have. Not try to race to the bottom. Instead, try to race to the top and continue to add value in manufacturing. That's what we need to do if we want to keep manufacturing and assembly jobs in the U.S. It's increase that value. And robots help us do that because they help the humans focus on what the human does best. Those are the cognitive level tasks. Those are the tasks that require some level of thinking. And let me put out another example. CNC machining. Computer numeric control came around about 40, 50 years ago. Did that take machinists out of the loop? Not at all. Not at all. It required machinists who understood how these systems came together, how the products came together. It took them to translate engineering drawings into a program that a machine could execute and then operate that machine. And so that, again, it requires a level of cognitive thought. CNC machinery didn't take machinists out of the loop. It allowed them to focus on what they did best. Same thing for robotics. And then let me offer a point of example here. General Motors has obviously invested in catching up with the Japanese primarily in industrial robots in the last 20 years. They do that because robots can maintain a much higher level of quality than humans can in doing those repetitive tasks. But sometimes people think of robots and they talk about this concept they think of as they call lights out manufacturing, because we don't need lights if robots are doing all the assembly. Well, actually, General Motors is investing $10 billion a year in human-robot interaction. So if they really believe in such a concept as lightweight manufacturing, why would they put money into researching how humans and robots are going to work together? General Motors knows that again, they need humans on the assembly line to do what humans do best. They need robots to do what robots do best. The repetitive tasks, helping them increase quality, increase efficiency, and use humans to work alongside them to perform the thinking level tasks that robots can't do today. And so again, robots will help the U.S. race to the top and continue to stay on the top when it comes to manufacturing and assembly because they'll help humans focus on what they can do best. We don't need to be chasing after large-scale repetitive manufacturing. That's not where we add value. We add value in doing things that do require cognitive level interaction from humans, and that's why increasing the intelligence of robotics and increasing the penetration of robotics in manufacturing will actually be a competitive advantage for the U.S. and help us maintain our position as the #1 value-added manufacturer in the world. And there's actually a national robotics initiative that was announced about 2 months ago by President Obama, and there's now been allocated $70 million in new money toward robots and advanced manufacturing because, again, there's a question about how does the U.S. maintain that leadership position? Well, one of the other pieces to that answer is making the right investments, and our country is starting to make some of those investments in the technology that it's going to take us to help maintain that position in value-added manufacturing. So now, here's my university side of the talk. What are the technologists of tomorrow going to be working on? Well, again, I mentioned there's been a lot of great work that's been done in robotics since really the 1960s. We in the military space have spent a lot of time working on unmanned vehicles, be they unmanned ground vehicles, air vehicles, underwater vehicles. A lot of great work. I mentioned Larry Davis from the University of Maryland, who's done some seminal work in computer vision that was applied on the autonomous land vehicle. People have also seen the work that has been done with drones or unmanned aerial vehicles in the news. So I think that, again, that just scratches the surface. But I think that there are a lot of technologies that many of the people in this room are going to embark upon in the next 20 or 30 years. So the robots today, they're actually pretty simple. They actually work on a fairly simple control mechanism where they sense their environment, and they build up somewhat of a three-dimensional view of that environment that might look a lot like dots, might look like pixels. They kind of map out what the world looks like in a very, very crude fashion. So if you think about how we would represent this room as a series of dots, you might be able to make out the tables and the chairs and the humans, but you couldn't discern one human from the next. Okay? Because if we look at our world as a series of dots or pixels, that tells us nothing about what's in that environment. Okay, so where we need to go in the future is we need to start not only recognizing our environment as a series of dots, which is largely how robots represent their environment today, we also have to know what those dots are, what they mean, and also how they relate, how the objects in our world relate to other objects, and how they also relate to other concepts in our world. Okay, and that's, by doing that, all of a sudden we've been able, what I call a semantic level of intelligence. And once we can start thinking about our world semantically, then robots can start working at a cognitive level, and again, solving problems that can't be solved today. Let me give you a very simple example. When you're driving down the road and you see pedestrians in your environment, you see pedestrians, say, on the sidewalk, they're following the trajectory of the sidewalk, you pretty much know that they're not going to dart out in front of you, and they're not going to put you in a situation where you have to brake very quickly. But if you see a child who's playing with a ball alongside that sidewalk, you create a relationship between the child, the ball, and the sidewalk. And you create that at the semantic level in your mind. You immediately know to cover the brake when you're driving, because kids playing with the ball, there's always a possibility that ball goes out into the street, the kid will react, try to chase the ball, you need to know to stop very quickly. And when we think of our world as a series of dots, we don't get those relationships. We don't get the relationship between the kid, the ball, the sidewalk, and the car. But we do when we can start thinking about our world semantically. And so the robots of the future, the technologists that are here today, need to start embarking on the technologies that will help us actually discover and maintain and reason upon those relationships that we find in the environment that robots are going to operate in. And that'll help them achieve a higher level of capability. That'll help us actually achieve autonomous navigation or driverless vehicles. But let me give you an even simpler example. If you think about how you put together a flashlight, where you have a flashlight base, you have a couple of D-cell batteries, you have the lens, you have the enclosure that needs to be closed. Again, when you think of your world in very simplistic terms, if you think of it as just pixels, you wouldn't be able to put together that flashlight. And the reason why is because that says nothing about the order in which those components need to go together. So again, the technologists that are here today and those who are embarking on study of robotics need to go beyond what's been done currently and need to be looking at technologies. Maybe they're artificial intelligence technologies. Maybe we have things that come out of cognitive reasoning, of cognitive psychology. Maybe there are technologies that can help us achieve that higher level of reasoning that's needed so that robots can start solving problems that can't already be solved today. So finally, what I also would offer the technologists in this room, when we think about robotics, we need to be thinking about what it is we're going to do with those robots. We need to think about the application that we're going to use the robot for. think about how we're going to use robots as tools to solve problems. And it's critically important that we look at robots as an enabler of humans. Like I mentioned, we wouldn't have been able to dig the Panama Canal, or we wouldn't have been able to have an industrial revolution without automated technology. Well, the problems that we're going to solve tomorrow are going to be very different than the problems we're solving today. We have our theories and speculation on what those are going to be, but nobody completely knows. But we need to be embarking on some of the enabling technologies that are going to help us get there. And so, as roboticists, we need to be thinking about what those applications are and how the user is going to use that technology to be much more effective at whatever job he has, or whatever the jobs of tomorrow are going to be. And then finally, again, because robots help us do things that can't already be done, or they help us amplify the capabilities that we already have as humans, robots can help us increase the size of the pie. If we think of again, value-added manufacturing, highly complex systems that we're building, we can use robots to optimize the use of humans, to use humans for the cognitive tasks that they do best, use robots for the repetitive tasks, and ultimately we can be building things, assembling things, manufacturing things that just can't be built by the brute force of humans. And so again, we're not using robots to replace humans, we're using robots to augment humans and enable humans to do much more. And that'll help the US maintain its position, again, as the #1 value-added manufacturer in the world. And I'll take any questions. Darryll.
Okay, it's a somewhat hard question, but I don't know what the easy answer for. You mentioned that this has got in certain ways and amplifies abilities, but most of that tends to focus on the cognitive side. That is, amplifies cognitive abilities, capacity, acquisition, smartness. If we look at the entire spectrum of the human race, we're always going to have a large component of that, people that are going to do organizations kinds of things. Any comments, thoughts? I know that's a hard one. I know that's a hard question, but I'm just any suggestions or thoughts about that aspect of it, about what happens to the guy who doesn't feel he has any particularly strong strengths that he can amplify.
Well, let me go back to the example of excavation, right? We had when we were building the railroads in the 1850s, the 1860s, we did that with a lot of brute force labor. As we started to use machinery, we were able to take some of those people who did the excavation and train them at using excavation devices, such as backhoes or steam shovels, and then those same people could continue to do excavation in very much the same way, in moving the earth around, but they could move a whole lot more of it around at the same time. So I would look at analogies like that to see what we could do with robots, because again, I think there are certain things, certain environments that we can't operate in, or even certain components or products that we're assembling just can't be assembled with machines. And so what we can do with the machine is we can do the repetitive pieces of the assembly or the manufacturing using the machine, and the higher level or the more value-added pieces of that assembly using the human. Because even if you look at in manufacturing, we have some level of skill in the labor that we're using to do manufacturing. That person still divides his attention between repetitive tasks and cognitive tasks at some level. So we want him to focus more on the tasks that the human can do best. So it's taking a look at the division of the allocation of tasks or the division of labor, and again, focusing the human on what the human does well, and the machine on what the machine does well.
So this is in part that issue about what we do with robots. We should probably be paying some attention to those issues of who can enable exploration, maybe some new areas that haven't been possible.
Sure, and that's why I think it's really important that as roboticists, we think about the application. We think about what the user is going to use the robot for. And the reason for that, again, is because we can't always think about what the use of the robot is going to be. So put that robot in the hand of the users, and like to your point, thinking about not how we're going to use the robot to keep doing what we're already doing. Let's think about how we're going to use robots to do what can't already be done, or what's already too dangerous to be done. And that's, right, we can get a real enabling or a real springboard effect from the use of robots by looking at it from that perspective. Yes?
Two areas I'd like to see what you think about robotics. Food production and energy production. We're really at a point where we don't increase our food production and energy production. That's like and so how do you see robots playing in food production?
Sure. So for those that couldn't hear, the question was about how we're going to use robots for food and energy production, and how we can use that to again, achieve more than we can without robots. Well, let's take energy. I think that's the easier of the two problems. Let's take energy. More and more of the energy that's being extracted is in extreme environments. When you looked at how we moved into the Gulf of Mexico in the last 30 years ago, we were in a very shallow environment. Well, today we're going farther and farther offshore, and we're going into a much deeper water environment. There's also talk about going into the Arctic to extract energy. Well, these are both environments that humans cannot operate underwater at that depth or in the extreme environments of the Arctic. And so as we see our energy production moving farther and farther into the extreme environments, we're going to need robots to help extract some of that energy. And in fact, we're seeing a lot of interest from the drillers today in doing more with the underwater vehicles that they already have. There's already a lot of use of underwater vehicles in energy extraction today, but they're starting to do more with that. And just think of this problem for a second. If during the oil spill a year ago, if there were a robot that were able to go to the bottom of the ocean and cut off the flow of the oil in the Gulf last year, how much money would BP have paid for that robot? $10 billion, $20 billion? Would have been a very valuable technology to have. I think food is the same way. We need to start producing more food per unit of land, and we also need to do that much more effectively and much more friendly to the environment. One of the things that helped us revolutionize agriculture 100 years ago was the mass use of fertilizer. But that's had a detrimental effect on the environment with phosphorus and with runoff. Well, one of the new ways forward in farming is to only apply pesticides and fertilizers where they're actually necessary. And so if you could think of trying to do that with a human, it would be very, very, very labor intensive. When we think about applying fertilizer and pesticide today with crop dusters, we can do that on a mass scale very easily. But if we were to walk the beans or walk a row of corn and have to discern and decide where to apply pesticides and fertilizers, it would be a task that would take a farmer far too long to accomplish. So if you can think of having robotic systems that could apply fertilizer and pesticide on an as-needed basis, number one, you can amplify the amount of production that can happen on the farms, and number two, you can do it in a much more environmentally friendly way.
So what I'm going to recommend would be the following. High school students are already beginning to approach the labs, and I know that some people who are sitting in this room need to be in the labs to make sure that they can start entertaining the high school students who are showing up here. So those people who need to leave can leave, and then I want to make some announcement, and then we can continue our discussion. Okay. So if those of you who need to be in the lab to make sure that you can entertain our high school student visitors, welcome towards the lab. Get up here. So some of the announcements are that autonomous vehicle lab demonstration location has changed. Autonomous.
I can say that. Because of the weather, the Autonomous Systems Lab, Gil Blankenship's lab with the vehicles, is not going to be outside on the Kindling Plaza as it says in your schedule. It's in room 1414 of the A.B. Williams building, which is the building right across the street from us. And also, I'll say one other thing. The information table that we were going to have out on the Kindling Plaza because of the rain, it's just going to be in the rotunda instead. So again, if you get lost when you're out there and you need direction, just come back into this building and that's where our information table will be.
Okay. And the box lunches should arrive here hopefully shortly.
They're here.
Okay, great. So you're welcome to pick them up as you go to the labs and labs to be open until 3 p.m. So that should hopefully give you plenty of time to visit the labs.
I think that's it. I think that's it.
Thank you, Becky, very much. Okay, so now we can go ahead and continue with our discussion.
So now I know my competition is with food here. Question in the back.
Intelligence of robots are very important and I think crucial. And question is, you show us samurai robot. What is intelligence of that robot? Because when I see the radio controller, that means no intelligence.
Sure. So the question is, what does it mean to be an intelligent robot? I think what an intelligent robot means is that it's making some level of decision without direct input from the human. And in the particular video that we showed, in some of those videos there was a human who was controlling it. But let me say one thing. First of all, even in that case where there was a human controlling it, there's no way that you could control that like a traditional airplane. If you think of a vehicle that spins around and only has one control surface, even the inputs that an operator puts into that vehicle do not go directly to the control surface. So even though you saw a radio controller in the hand of the operator, and I think one of those operators is actually here today, even though you saw a radio controller in the hand of the operator, he's giving it commands that are go left, go right, climb, descend. He doesn't have direct input to the control surfaces because with this kind of a novel vehicle, it's just not possible for a human to think of all the variables that are involved in controlling it. But then to your question more generally, what is an intelligent robot? Again, those are where the robot is sensing its environment and making some level of decision about that environment in closed loop. And where I think we need to go with robots in the future is have them making decisions at higher and higher levels. Let's take the autonomous cars or the driverless cars that we've seen, for example, in the DARPA Urban Challenge or the Google autonomous driving vehicle that we're seeing today. Those vehicles perform one application, and that's navigate from point A to point B, and they avoid the obstacles that are in their way along that line. But let's think about what we're really trying to do with these vehicles. Take again the drones or the UAVs that we have deployed today. We're collecting a lot of imagery with those vehicles. Sometimes we're using them in applications that go even beyond that. Again, just like the agricultural application, we don't want to collect all the information. We only want to collect the information that we really want to see. And so if you can close the loop, that intelligence loop, around what the application is, around what the user is really trying to do with the robot, and help the user solve that application, that's intelligence. And we need to continue to go farther and farther, moving beyond navigating and moving into automating the application or the use of the robot. And again, I think we'll see a lot more value out of robotics and unmanned systems by doing that. Let me give you an example. The Predator unmanned aerial vehicle that the Air Force and the CIA use, the support chain for operating a Predator is somewhere in a range of 100 people. So we like to call these unmanned systems, but they're not unmanned by any means. They may not have a man in the platform, but it takes a lot of people to operate these systems. Many of those people are doing mission planning or deciding where this Predator is going to go. They're looking at the imagery that comes back from the vehicle. We need to automate more of that so that we can continue to use the people that we have much more effectively and to try to reduce the logistics trail that it takes to operate a vehicle like that. And all of those are applications of higher levels of intelligence being applied to robotics. Another question in the back? Yes.
Yeah. Two things. One is that how do you separate the automation with robotics, if there is any separation? Number one. And number two, what is the impact of robotics or overall automation on socioeconomics of the societies, communities, and the country, and so forth?
Okay, so the first question is, how do you separate, or is there a separation between robotics and automation? And the answer is, I think there's a lot of overlap between robotics and automation. Robots traditionally adapt to their environment, but they also help us solve tasks that require some level of automation. And I think that you're seeing cross-pollination between those two areas. Technologies that come from automation into robotics and vice versa. Technologies that come out of robotics, such as driver's aids, adaptive cruise control, that come from the robotics environment and go into automation of other technologies. Second question about what are the societal and economic impacts of robotics. Well, I've mentioned a number of them. For example, medical robotics help people get through surgery with less loss of blood, with lower recovery times, and also by helping the surgeon be much more careful at using the hands that he has. So that's one societal benefit of robots.
What about negatives? Can you think of automation as negatives, such as, say, in food industry, these days we go to grocery stores, people don't eat less, population has increased, so these corporations are making more money, more profit, but we have so much unemployment. So you go to grocery stores, out of 10 cash registers, 8 of them are automated cash registers, which there are no human beings, so therefore, you go automated. I refuse to go, of course, but my point is, those are negative impacts as well. As engineers, we really gotta look at all the dimensions of the automation and its impact on socioeconomics, not only the positives. I can see the positives definitely.
Sure. So to get to the positive impacts, what I think is most important for us to do to make sure that robots continue to have a positive impact is to focus on the applications that humans can't do without the use of robotics. And there are many of those. And so when you think about those applications, those actually not only do they allow robots to penetrate into society, but also they help us build a bigger pie. They help us manufacture things that we just can't manufacture without the use of robotics. Same thing with when the assembly line came about 100 years ago. We couldn't repetitively build cars the way that we did prior to that. Well, by using the assembly line, we were able to build far more cars than we would have ever been able to build without it. So we need to use the technology to enable us to grow our society and to grow the economy, and not necessarily to shrink it. Yeah, question here in the middle.
What's your opinion on cloud robotics moving forward?
On, you say cog or cognitive?
No, cloud.
Cloud.
Cloud robotics.
So in terms of cloud robotics, so I want to understand what you mean by that. So you're talking about intelligent decision-making technologies that might exist in a cloud, and a robot would use them as a service? Yeah, I think that's going to be just as we see cloud computing growing. I think you're going to see the use of services that come out of the cloud being important for robotics, so long as those robots can remain connected to the cloud. You also have an example or an issue, I would say, in say a military environment where you're not always connected to the cloud, or there are security issues in being connected to the cloud, and so you also have to be able to provide those services, say locally to the robot, so that the algorithm is still available.
Okay, but that's the last question.
Hi.
Okay.
Go ahead.
I'm Don Probst, and I work for FIRST, so thank you for the plug. And if anybody has any questions about FIRST or how they can be involved, please say them.
Thanks, Don.
Maybe we should now take the question. You're more than welcome to come here and talk to the speaker, but some of the people may want to go sit down. I want to thank Gupta very much.